Okay, truth tables. You have a set of inputs, and the inputs can be true or false, 1 or 0, high voltage or low. The two options, 0, 1, 0, 1, 0, 1, 0, 1, I am examining in different cases. These are the only 4 responses you could have to a single input. So if X comes out at 0 volts, no matter what you do, that's just a dead wire. You don't really need a circuit. You just need a wire that ties to the ground. On the other hand, if it's 1, 1, again, it doesn't matter what A is. That's a live wire. That would simply be a wire that you connect to the 5-volt level. Again, no circuit required. If A is 0, 1 and X is 0, 1, this is just X equals A. If you already have the input, the input itself is the output. So again, you don't need a circuit. The fourth case is the interesting one. When A is 0, X is 1. When A is 1, X is 0. This is called X equals not A. How do we flip or invert or swap the true-false? So a NOT circuit you can build with a transistor, a resistor, a 5-volt line and a 0-volt line, and the output is read here. Okay, what's the resistor for? Well, it's to create a voltage drop. If there's a current flowing, that's because A was high voltage, and if the current's flowing, X is connected to ground. So when A is 1, X is 0. What if A is 0? Then current is not flowing. Well, if you have a resistor, V equals IR, but there's no I, so the V is 0. There's no difference in voltage here, which means the X is at 5 volts. So when A is at 0, X is at 5. When A is at 5, X is at 0. This is a NOT circuit. It requires one transistor, logic gate, and one resistor. That's the NOT circuit. And that's everything you could possibly do with only one input. What about 2 inputs? In the case of 2 inputs, you have A and B. You now have 4 possibilities. They could both be 0, could be 0, 1, it could be 1 and 0, or it could be 1 and 1. Now, how many different outputs could I get? I could have 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 1, 0, 0, 1, 0, 0. There are 16 different possibilities. So here we have a list of every single possible thing you could do with 2 inputs in a truth table. Every truth table would have these first 2 columns, the A column 0, 0, 1, 1 and the B column 0, 1, 0, 1. Then I listed out everything that could be an output. So we could have done this as 16 completely different tables, which is how it would normally be presented, but that's just tedious. I figured I'd be efficient and put them all together. This looks like a lot, but it really isn't. We're going to find all the boring stuff and then find all the interesting stuff. So let's get the boring stuff out of the way, and that'll be quick. X1 is all zeros. X1 is a dead wire. X2 is our first interesting one. This is called A and B. It is only a 1 if A and B are both 1s. X3 is one of the trickier ones. We'll come back to it. X4, 0, 0, 1, 1. Now looking at this, we can see that A is 0, 0, 1, 1. X4 is simply equal to A. So that's boring. Why would we bother with a circuit? X5 is one of the tricky ones. X6, 0, 1, 0, 1. 0, 1, 0, 1. That's just B. So X6 is B. X7. Now this is an interesting one. This is called exclusive OR. That's A XOR B. X8 is a regular OR. A or B. Now the difference between these, in everyday English, OR is ambiguous. It could mean A or B but not both, or it can mean A or B or both. And we use them in both ways often. But mathematicians have to be more precise. So they have to specify the difference. If it's one or the other but not both, that's exclusive OR. 0, 1, 1, 0. So if you've got one of them a 1, one of them a 1, it's a 1. But if they're both 0 or both 1, that doesn't count. x8 is almost the same, 0, 1, 1, 1. But that is an inclusive OR because it's also a 1 if they're both 1s. So essentially, if you have any 1s, you get a 1. And that's x8. x9. Interestingly, x9 is exactly the opposite of x8. See, their exact mirror image. So we could say that x9 equals not x8. And we could describe that as saying not acting on A or B. And that is, we have a shorthand for that. It's called A nor B. And it is what it sounds like. It is only a 1 if neither A nor B is a 1. And that's what we have there. x10 is interesting because it's the mirror image opposite of x7. And x7 is exclusive OR. So x10 is actually A x nor B. I don't know why they decided to go with x nor. x11, 1, 0, 1, 0. That sounds like a simple pattern. What is that? x11 is not B. x12 is one of the complicated ones. x13, 1, 1, 0, 0. Well, that's just not A. x14 is a little tricky. x15 is the exact opposite of the AND. 1, 1, 1, 0, 0, 0, 0, 1. x2 was A and B. So this is called NAND. So x15 is A NAND B. And finally, x16 is just a live wire. That's boring. You don't need a circuit for that. You just connect it to 5 volts and you're done. So how many did we skip? 3, 5, 12, and 14. And 2 of them are just not of the other 2. This is essentially saying, x3 is saying you will get a 1 if A is true and B is not. If A is a 1 and B is a 0, then you'll get a 1. So in other words, that's A and not B. So x3, A and not B. The next one we skipped was 5. And sure enough, that's B and not A. x12 is the exact opposite of B and not A. So x12 is not x5. So it's a not on B and not A. And x14, finally, is the opposite of x3. That is every possible result that you could get from 2 inputs.